This is JoseAlatorre with my final presentation. The name of the project is Deep Learning Trading Portfolios, and the objective of the project is making an analysis, an exploration of a deep learning framework proposed by Xiang, Yu, and Liang with the objective of trading cryptocurrencies. I'm gonna base my project in the code of these authors. I create some modifications of the same code, and also I create a zip file that is going to be easier for you to run. It also contains a pip file, so the environment is ready to run. In this project, I will only focus in one of the on one of the models proposed by the authors. The model is a convolution network, a convolution neural network. I think it's very interesting to see how we can use the models that we learn in class to do image recognition for creating trading strategies. The first part, like the technologies used, I'm gonna use the PG portfolio library that was developed for the authors, and that's gonna be the base of the code and the models. And also I'm gonna use TF-Learn. TF-Learn it's an API, but that fully interacts with TensorFlow. So I will put TF-Learn like somewhere between Keras and TensorFlow, because it allows us to build the models in a sequential fashion as we were using with Keras, but also allow us to use the full functionality of TensorFlow. For example, using the TensorBoard and other analysis. So I think it's very interesting in this project actually see how the TensorFlow and TF-Learn are mixed together, and how a complex model is also built. The data. So which data I'm using? I'm not using the data that the authors used, that is Coinbase. I'm using sorry, I'm not using Polynex, that is the authors. I'm using Coinbase, and I'm getting 1 minute bars on the last year of data. What is a bar? Well, a bar is it's a tensor. Now we are in deep learning. It's a tensor that has 4 dimensions, has open, close, low, and high. I'm gonna use all these dimensions to see if a model can recognize patterns in cryptocurrencies and see if we can find a trading strategy. The extraction of the data was a project by itself, very complex ETL. It was a thing to build the data. So if anyone of you is interested in getting the full data, please let me know, and I'm happy to share it. Data selection. So the authors uses only 11 cryptocurrencies. For this project, I'm only using 4. Why? Because it's very slow to train the model with 11 cryptocurrencies, and given that I'm not using Amazon Web Services in my computer, it took too much time to actually do tests and be able to explore the model. So how's the description of the project? Well, the description of the project, as I mentioned, we're gonna have our tensors. Our tensor is gonna be this X, that is gonna be, has 3 dimensions. It has the lower price, the highest price, and the closing price, that is VT, in a 30-minute bar, okay? Now we are gonna normalize all our tensors by the closing price at the beginning of the time series. Why this? With the objective that not create any dimensionality problem, as the prices of the different cryptocurrencies are considerably different. What's the objective function that we're gonna use here? Well, our objective function is we want to maximize the return of our portfolio, and the return of the portfolio, the log returns is simply the weights, okay? The weights multiplied by the allocation that we have. The weight is by the returns on each of the assets during all the life of our portfolio. Also important to mention is that when we are maximizing the return, we are using a window of 52 observations. And what is 52 observations? 52 observations is a running window of 52 30-minute bars. What's the architecture of the network that we're going to explore? Well, So the authors, one of the architectures that the author used, it's a convolutional network. It starts. This is the diagram. I'm gonna go in deep in the code, but basically we start reducing the dimensionality of our problem until we translate our tensors into a set of weights. What is very interesting in this setup for training is that in comparison with images, the filters that we're using filters in the length of time, but we are not using filters touching several rows. And what I mean by several rows, I mean like each row is one cryptocurrency. So here the filters will only move row by row, will be dimensions of 1 by n. We'll see. So let's start with the topology of the networks. The first layer is it's a convolutional layer where we will transpose our data. Our data, we have like 3 tensors, and we have the dates in as rows and the cryptocurrencies as columns. We are transposing this, so each row corresponds to each cryptocurrency, and the columns corresponds to the date. So when we are creating filters, as I mentioned, the filters here have a dimension of 1 by n. So why the authors do this? The authors do this because they say, like, we want to extract characteristics only on the first layer by each cryptocurrency, and then as we reduce this dimensionality, we can start trying to find characteristics in common. That I think is something very interesting of seeing the same process of feature extraction that we were using in image recognition. The second, after the first convolutional layer, as I mentioned, that was only of shape 1 by 2, the authors do something very interesting. Is that they reduce again, but only by cryptocurrency. I didn't have time to actually see what was the meaning of the filters, but I think that one of the next steps to really, as we did feature extraction and we analyze the shapes and the meaning of the filters, will be very interesting to tell us what these filters are doing. Yes. And by last, so the authors, what they are doing is they are creating a voting layer. But most interesting in terms of coding and implementation is how they are adding into this model the previous weights. I think this is something very powerful of DeepLearn because we have built all the layers in a sequential, or let's say building block fashion, but this also allows to introduce other tensors, that is a time series of different weights during the life of the training window. What were my results? Well, the first iteration, I used a history window of 50 observations, the first day with 10 filters and 80,000 steps. That was the parameters that the authors used in the paper. It's important to notice that in this model there is not the concept of accuracy, because we really know our like 50 classes that we already know. So we are actually plotting the benefit. And why is the benefit? The benefit is basically the total return of our portfolio. And that's the objective, the loss function that we are maximizing or minimizing. What were the results? So it seems that the benefit converged pretty quickly, right? It seems that after the first 30 epochs, the model converged. Then I decided to change the number of epochs and also the size of the first dense layer to 3 instead of 10, and then you can really see that the model doesn't learn characteristics as fast. What were the conclusions? Well, after running a few iterations of the model, it's clear that there is opportunity for the usage of the convolutional neural networks in trading. However, the results, rather than to point to conclusion, they point to bigger challenges. The first one is with such a high number of hyperparameters, as you will see in the model, more computational power is needed, and you may run many iterations with different combinations of this hyperparameter, and it will be hard to actually fine-tune. And for me, the biggest challenge here is really translating all the developments and advances that has been done in image recognition to find trading patterns, particularly in the sense of feature extraction and trying to give an answer or a meaning of what the filters mean. So here's the link to my videos. I also have a full GitHub repository with the full code. I also have a database with the full database, but you can also ask to class and you can get the sample code. Thank you very much.